In this section, we're going to solve what we call literal equations. Now, the equations that we've been working with are equations that have looked like this, and we've been asked to solve for x. Well, the difference is that a literal equation will look something like this, and we'll be asked to solve for one of those variables in terms of all of the other variables. So what's going to make these different is instead of us being able to just combine like terms and come up with a solution like x equals 8, we'll now be asked to solve for one variable in terms of all of the other variables. That means that your solution is going to have some letters in it. We're going to do a few examples, and why don't we just start with the one that's there, the ax plus by equals c. What if we were asked to solve for, let's change it up. Let's say we're asked to solve for y. Well, that means, folks, that we're going to do the same procedures that we've been doing. We're going to get y by itself. So the first thing we want to do is get anything that's being added or subtracted from y over to the other side. So now our equation will look like this. And you'll notice that c and ax aren't like terms, but that's okay. We're just trying to get y alone. So what would the next step be in that problem? Well, we want y by itself, and it's presently being multiplied by b, so we're going to divide all of the terms, every side, the left side and the right side, by b. And that leaves us with y on the left side, and we can keep the right side in this notation. So we would then say our solution for y is c minus ax all over. Let's look at this example. You'll notice this is, if you're curious, the area of a triangle. This is our formula. But in this problem, we're just asked, let's solve for h. That means, folks, we want to get h by itself. Now, here's one thing that I think is a little bit prickly, and that's the fact that I have 1/2 multiplied to both the b and the h. So what can I do to get rid of that 1/2? I can multiply by the reciprocal of 1/2. And folks, remember, if this is all being multiplied, I have 2 over 2, so that eliminates my 1/2 on the right side. And on the left side, I have 2 times a, that's 2a, and then I currently have b times h. I'm still trying to get h alone. So my next step in this, that's right, I'm going to divide both sides by b. And that would leave me with h on the right side and 2a over b on the left. And then using our symmetric property, I would write my solution as h equals 2a over b. All right, so here we're asked to solve for a in this equation. That means, folks, our objective is we want to isolate a. We want to get a by itself. So I'm going to take you on a different approach because in this problem, I think the easiest thing to do would be to move everything over to the other side that I possibly can. So one thing I'm going to do is, again, the fractions. I want to get rid of those. So I'm going to multiply both sides by 2 over 1, since 1/2 is being multiplied to the entire side of our right side of the equation. So those two go away. I've got 2 and the 1/2. That leaves us on the left with 2t. And then on the right, I have this business. I'm solving for a. I'm solving for a. So I could distribute, but guess what? I'm not going to. And that's because I just want to get rid of that h first. So you'll notice here, The h's on the right cancel out. That leaves me with this little fancy term of 2t over h equals, and now I've got a clean a plus b. 2t over h equals a plus b. I want a by itself. I'm trying to solve for a. So then here comes my next step. I'm going to subtract b. Keep in mind that 2t over h and b are not like terms, so I can't combine them. But then that leaves me with my solution of a. 2t over h minus b. Now let's try this one. So we're asked to solve for c in this equation. So again, the objective is we want to get c by itself. So I'm thinking the first thing I want to move over is the 7. So that leaves us with c over l equals, keeping in mind n and 7 are not like terms, so I leave them like so. The last thing I want to eliminate is that L that's being divided into C. So what I can do is use the inverse. If it's being divided, then I want to multiply both sides, people, sides by L. Not just one term, not just two terms, all the terms. So when we do that, those L's cancel, which is nice. That gives us C. And here, I'm then going to distribute the L to both terms on the right side of my equation. And that leaves us with C equals Ln plus 7L.